Hi friends, welcome to my next video session. So in this session I am going to discuss about recursion in C language and what are the types of recursions and how to write a program to find the factorial of a given number using the recursion. So first of all, let us see what is meant by recursion. So the process of function calling itself is called a recursion. We know that function is a subprogram. Okay, and we know what is a function call. In our previous videos we have discussed. So a function, when we call a function, the control goes to the function, okay, from the calling function to the called function. Okay, so here instead of control going to some other function, control comes back to the same function, then we call it as recursion. So in recursion, the solution to the problem depends on solutions to the smaller instance of same problem. Okay, solutions to the problem depends on solutions to the smaller instances of the same problem. That's why recursive function is a function that calls itself during execution. So there are two types of recursion. First one is called direct recursion and second one is called indirect recursion. So let us see what is meant by direct recursion. So in direct recursion, you can observe in this figure a function calls itself directly. So you can observe here function 1, here we have written or we have defined function 1. Okay, so this is function 1. Okay, so this is body of the function 1. So in body of the function 1, we are calling the same function. See, this is the function call. Now the control should go to the function which is defined. Okay, so what is name of the function here? func1. So we are within function func1. So control goes back to the same function. Means instead of control going to some other function, control goes back to the same function. Means the function calling itself. Function 1 is calling itself. See, function 1, within function 1 we have another function call to the same function 1, and this is called a recursion or a recursive function. We'll say function 1 is called recursive function because it is calling itself. Okay, so in this process of recursive function, there must be some means to come out of the function. So for that purpose we need to use some condition. So based on that condition only, we will decide whether to continue the same function or we should find a means to come out of the function. Okay, so that we can understand through an example here. See here, one example we have taken. So the name of the function here is fact. See, int fact int n. So this is function header. Okay, normal function header. Within that we are calling the same function. See, this is body of the function. So this is body of the function. So in body of the function, what we have written, if n is equal to 0, so here n, so it is passed from other function. Okay, say for example from main function, this function fact is being called. Okay, so in main function, suppose if we say we have declared variable number scanf num, so that num is passed here. We are calling fact of num. So value of num will be copied into n here. So n is the formal parameter. So now here the value of n is what's called verified. If n is equal to 0, return 1. See, this is the condition. This is the condition which allows us to come out of the function fact. Okay, suppose this, if n is equal to 0, return 1 is not there, then there is no means of coming out of this function, recursive function fact, because we are calling the function fact once again. Repeatedly we are calling fact. So that's why some condition should always be there in any recursive function to come out of that function. Okay, so if n is equal to 0, then we call it as, we return 1 to the calling function. Otherwise, if this condition is false, n is not equal to 0, then what we will do, return n star fact of n minus 1. Means the same function is being called with the smaller instances of the same problem. So that's why we are calling same, return n star. Once again we are calling here fact. See, name of the, what is name of the function in which we are fact. So we are within the fact and calling that fact once again with n minus 1 value. Means now the control goes back to same function fact by copying n minus 1 into n. Now n minus 1 will be actual parameter and n will be formal parameter. So this process repeats. This process repeats, reoccurs. That's why recursion means reoccur, recursion. So this process repeats until value of n becomes 0. See here, value of n return n star fact of n minus 1. So every time we are decrementing value of n. So at some stage value of n becomes 0. So if n becomes 0, then we send return 1 to the calling function. And return 1 to the calling function. So this is called direct recursion. Direct recursion means we are directly calling the function. Okay, function which is calling itself is called direct recursion. So in indirect recursion, what happens? Second, we shall see indirect recursion. In indirect recursion, what happens? A function calls another function, and that function in turn calls back the original function. So that is called indirect recursion. Okay, means indirectly, see, function 1 is called. Okay, see here, for example, you can observe in the figure. Here we have function 1. Okay, function 1 is being called here. Okay. So in function 1 we are calling function 2. Now control goes to function 2. In function 1 we call function 2. There is a function, there is a call to function 2. So now the control goes from function 1 to function 2. So now in function 2 body of the program we are calling function 3. Okay, there is a function call to function 3. Now the control goes to function 3. So in function 3 we have a function call to function 1. See, function 1 is called back. Here, control comes back to function 1. How did we reach to function 3? We reached function 3 through function only, because in function 1, function 2 is called. So, function 2, in function 2, function 3 is called. So, in function 3, function 1 is called once again back. So, that's why function 1 calling itself, but not directly. It is indirectly through function 2 and function 3. Hence, this type of recursion we call it as indirect recursion. Usually, very rarely we come across or we make use of this indirect recursion for your academic curriculum. Okay. So this is all about the types of recursion. So let's see one example program to discuss about the factorial of a number using recursion. So here is the program to find factorial of a number using recursion. We know that factorial of a number is computed by means of, say, for example, 4 factor means 4 into 3 into 2 into 1. So like that. Okay. But factorial of negative numbers is not defined, right? So with that concept we shall discuss the factorial of a number using recursion. So this is the comment hash include stdio.h. So here we are using function declarations, a function prototype. Int factorial means in my program I am using a function whose name is factorial with parameter integer, with formal parameter integer. You observe here we have not mentioned variable name here, not necessary. So the data type of the variable is important. So this is also valid. So this you have to note, don't get confused with our earlier function programs. Okay, you can write here integer n, no problem. This way you can write integer n, no problem. N is the formal parameter. Even if you don't write, it means that the formal parameter is integer type. So that is enough. Okay, right. So here for function prototype it will do. Semicolon here we are. See, main function, we are in the main function. Okay, so we have declared 2 variables, number and result. Clear screen. Now you have to read the input number. See here scanf. In scanf we are reading the number. So what is our variable? Num, integer. So we are reading num. So scanf is preceded by printf statement. So enter the number, scanf number. Now it will check if number is less than 0. Just one error message is displayed saying that factorial of negative numbers is not possible. See, if number is less than 0 means given number is negative. Then condition is true. When this condition is true, before else part is executed means this is executed and else part is skipped. So from here to here it will be skipped. Directly control comes to end of main. Okay, right? If number is negative. Suppose if number is positive, then this condition becomes false. When the condition becomes false, before else part is skipped, so else part is executed. This is executed. So when this is executed, what we have written here, result assigned a value factorial of num, means we have written a function called factorial, whose prototype already we have declared here, factorial. One function is defined, okay, which returns integer value and which takes integer input, okay, that's what here. So factorial of num we are calling. So num value here, so for example 4 is the value of num, then we are passing 4, factorial of 4, it's nothing but factorial of 4. Now the control comes to the function called factorial. See, it does not execute the next statements in the main directly. Now the control comes to function defined called factorial. So here we have defined a function called factorial. See, as per our prototype function declaration, integer factorial int. No semicolon, here semicolon should not be written. See, here int factorial int n. So this n is the formal parameter. So here factorial of num, we are calling factorial function with actual parameter num. Suppose if we have considered num as 4, that 4 will be now copied into n. So n value becomes 4, like that. Now here we have written if n is equal to 0 or n is equal to 1, then return 1, because factorial of 0 is 1. Please remember, factorial of 0 is 1. Suppose if your input is 0, then return 1, means to the calling function. Here we have called now, at this point return 1 comes, that will be copied into result. Now the value of result is displayed here by the next printf statement. See, the factorial of percentage d is equal to percentage d comma num comma result, right? So like that. Suppose if n value is 1, then also return 1. Okay. Suppose, so actually this is the condition for us to come out of this factorial by recursive approach. Okay, if this condition is not there, if this part is not there, so we cannot come out of this factorial. So to come out of recursive function, we must always use some conditional approach. This is what the conditional approach based on which we will come out of this function. Okay, so means we will come out when n is equal to 1. Otherwise what else? Suppose n is not equal, this n is not equal to 0 or n is not equal to 1, then this is skipped, because condition is false. This is skipped, else part is executed. So what else part says? Return n star factorial of n minus 1. See here, same function is called. What is name of the function? Factorial. So same function is being called once again with n minus 1 value. So return n star factorial of n minus 1. N is 4. Now this becomes factorial of 4 minus 1 means 3. The 3 will be copied into n. Okay. So process continues like that. Okay. So finally when the value of n becomes 1 here, because every time we are decreasing the value of n minus 1, n minus 1, n minus 1 like that. When n becomes 1, then return 1 to the place where it is called. Okay. So whatever the final value that is returned from this function, so comes back to this factorial call. Okay. And that will be copied into result, and value of result is displayed by using this printf statement. So you will understand it better if we trace the program. So let us trace the program and see what will be the result. So always execution, C program execution begins from main. So main here. So integer num comma result. So two variables in num and result are declared. So memory is result for num, okay, and result. So just memory is result. Values are not yet stored. Okay, they are case sensitive. Please, for tracing purpose, just tolerate. Now, clear screen. Screen becomes blank. Now enter the number. So it will display enter the number. Enter the number on the screen. Right. Let us see here what will be the output. Enter the number. Enter the number. So whatever is there, so that will be displayed here. Enter the number. So number is displayed. Then scanf num. Cursor is displayed here. So scanf num means you have to give the input. Let me give input 4. Press enter. So when you press 4 and enter, that 4 will be copied into which variable? NUM. So in NUM now the value becomes 4, right? Then if number is less than 0, is my number less than 0? 4, is it less than 0? No, it is not less than 0. Condition is false. When the condition is false, else part is skipped. Else part is condition is false, means before else part is skipped and control comes to this portion. Now this is executed. So what is this? Result assigned a value. Now result assigned a value. Factorial of number. Now factorial function is called. Let us see. Factorial function is called factorial of number. What is value of number here? 4. Factorial of 4. Okay, called. Now result assigned a value, this one, factorial of 4. Now control comes to this factorial function. Factorial number value is copied into n. So what is number value? 4. Now it is copied into where? N value. N becomes now 4. Clear? Now here it is tested. If n is equal to 0, is n is equal to 0? No, 4. Is n is equal to 1? No, it is 4. So false and false is equal to false. False means when this condition is false, this is skipped. Before else part is skipped and control comes here. So what is this? Return now at this point. Okay, return factor n star n. What is value of n? 4. 4 star factorial of n minus 1. So n minus 1 means how much it is? 3. 4 minus 1, 3. So this it becomes. Okay. Now see here, once again we are calling factorial of 3 here. So factorial of 3 is nothing but what? Factorial of 3. So this becomes what? Return 4 star factorial of 3 is nothing but what? Factorial of 3 means now n minus 1, 3 is copied into n. So value of n becomes how much? 3. Okay, right? So now if n is equal to 0, is n is equal to 0? No, it is 3. Is n is equal to 1? No. False or false? False. So this is skipped. Okay, so else part is executed. So what is else part here? Return means in this place we write return n star. What is value of n? 3 star factorial of n minus 1. 3 minus 1, 2. Right. Now here once again factorial function is called. See, once again factorial function is called. Return 4 star, return 3 star, factorial of 2. So once again factorial function is called with 2. So now factorial function here with 2. 2 will be copied into n. So now n becomes 2. If n is equal to 0 or n is equal to 1, is n is equal to 0? No. N is equal to 1? No. So false or false? False. Means condition is false, means this is skipped. Before else part is skipped. So once again else part is executed. So what is else part here? Return n star factorial of n minus 1. So this becomes what? Return n star. What is value of n? 2 star factorial of n minus 1. So 2 minus 1, 1. Right. Now once again factorial function is called with what? Here see, once again factorial function is called with input 1, parameter 1. So now 1 factorial function once again called with 1 will be copied into n. So now n becomes what? N becomes 1. Okay, then if n is equal to 0 or n is equal to 1, now yes, n value is equal to 1, means this condition becomes true. N is equal to 0 is false, n is equal to 1 is true. So false or true is true, So that's why return 1. So return 1 means here the function is called at that point return 1. Return 1. So return 1 means 1 comes back here. Okay. Now this is nothing but what? Return return 2 star 1 is nothing but 2. So this is nothing but what? Return 4 star, return 3 star 2 is nothing but what? 6. So this is nothing but what? Return 6 into 4, 24. Okay. So now 24 is returned to the function, main function where it was called. Now here it becomes 24. So this becomes result assigned a value 24. Now see, result becomes how much? 24. Okay. Now the factorial of it will display. The factorial of same thing. The factor in new line. So it will display the factorial of percentage d is equal to percentage d num comma result. In first place of percentage d num, what is value of num here? 4 is equal to, in second percentage d blue color, result variable blue. So what is result? 24. 24. So that will be your output. So factorial of 4 is equal to 24 will be your output. Okay. So then get ch, end of main program. This is how, so you can execute or you can write factorial of given number using a recursive approach. Okay. So this is all about recursion. So please watch the video repeatedly, you will understand it better. Okay. So even we shall execute the same program and see what will be the result. See, same program is copied here. Enter the number, scanf number. If n is equal to less than 0, factorial of negative numbers is not defined, else result assigned value factorial of number. So then when the control comes here, factorial of integer number. If n is equal to 0 or n is equal to 1, return 1, else return n star factorial of n minus 1. Okay. Enter the number, I will take 4. See, factorial of 4 is equal to 24. Now I will give, once again I am going to run it. Enter the number, I will give 0. Let us see. Factorial of 0 is equal to 1, because there we have, so here we have, if n is equal to 0, return 1 to the calling position, return 1. So when return 1 means at this position, here the function called return 1 means this becomes 1. So result assigned value 1. So factorial of 0 is equal to 1. So that will be your output. So factorial of 0 is equal to 1 is your output. Right? Even you can execute it once again, you can give 5. See, the factorial of 5 is equal to 120. So this is how, so you can write recursive programs. So thank you for watching my video.